Hi, my name is Armin Ainilian. Uh, I'm presenting this video to basically to make uh, the development of a GUIs simple with using this STM32F7 discovery board or boards, which runs on bare metal, and it also has a nice touchscreen display, and with a plethora of peripherals like USB, I2C, CAN bus, SPI, SDIO, UART, GPIO, audio inputs and outputs, and Ethernet. This STM32F746G discovery board and the likes of it are basically very inexpensive. Like about $56 buys you an ARM's Cortex M7 microcontroller that runs on 216 megahertz, has onboard flash, 4 meg by 32 SDRAM, and you can basically write a lot of interesting codes and have, since it has a display built in, you can, and then it's touchscreen, you can do your human interface GUI applications in bare metal and write your code and everything together and have it boot up in a second and you're ready for business. So let me show you what I mean by this board. Here's a picture of it. Okay. I got too many things open. Okay, so this is the picture of the board. As you could see, it's got a nice LCD display and touch screen, and on the other side, if I can scroll down, you can see all the slew of peripherals that you can connect: external sensors, image sensors, cameras, SD card, USB, Ethernet, audio input, output, and speakers, push buttons. It's got these headers that is basically Arduino 3 compatible. So a lot of the SPI and I2C pins and the GPIOs come from here. And you can basically make a little board and attach to it, and then you can control motors, stepper motors, PWM, servo motors. You can receive basic put sensors, like, and put it to ADCs, and then look at the data. Of course, this is kind of like a rundown of what the board looks like here. Okay, so it's got, you could see all the interfaces kind of named out. So there you go. This is basically what I want to just kind of quickly glance over. But but if you want to run other applications like Windows and Linux, I think that would basically load up the operating system requirements, and then that's when things take longer to boot up. What I like about this board is, like, this flow of development is, it's bare metal, it's quick, dirty, and you just want to basically control a motor or look at some external image or something, and then take some action, and you power this puppy up, and then it's ready to go. Okay, so now that I've showed you how the board looks like, you can go to the user manuals and the microcontroller architecture manual. Basically, it tells you all the register definitions, and I will post these links in this video, attached to this video. So anyway, and also here's like this. What I do is I use called HAL. ST Micro uses HAL hardware abstraction layer drivers, and here's the definition. Basically, instructions file of how these API drivers are configured to be used. You can also look. Basically, you build like this is the flow I recommend. Okay, and this is not the only one way of doing this. There's other ways of doing this, like external, like there's Embed, which is an online development system. You can use Embed, and you can do your code development using Embed code. But I'm just going to display. Let's show you how to do the through the IDE, CubeIDE. So what you do is you go in there and you open the CubeIDE. By the way, there's links for downloading it. I will display how to download the IDE through this link over here, and then also and install it. Of course, you have to register your name. So the first thing when you open it, you're going to configure your pinouts. So configuration of the pinouts, you're going to go in there and you say, oh, I want some PWMs. So you set up your timers. If you want some analog signals, ADCs, you set up your ADC. You select your pinouts. Let's say I want an ADC, and I want it on input channel 0, and then I want to configure the GPIO settings, and the GPIO settings are on basically here on this pin, and this basically, if you expand it, it'll probably tell you where the GPIO is coming at. So after this GPIO, it's on PA0 on the GPIO. So after you select your GPIOs, you click on them and ready to go. You go here and then generate the code. It generates the code, and after generating the code, it puts like the drivers and all that stuff for the pinout initialization and the configuration. You basically creates the main C file, and in the main C file you can start writing your code to test all these GPIO stuff that or the ADC or timers and all that stuff that you created. So you got your code, and the initialization is done in here in the main. So this is like the initialization of the clock and the oscillators and the timers and the ADCs. So this is going to come into handy later on. So now that after you're done with this in this workspace, okay, you basically are done writing your embedded hardware layer code. Now, how you do the GUI application user interface, you know, putting a nice human user interface, graphical interface to this. So what I recommend is using the embedded wizard platform. Now, there's other platforms you can use. There's one called TouchFX, but I just picked this one, okay, and then it's free to download. It's not the final version is not free, but just to get started, it's free. So I would go ahead and download the embedded wizard platform. I would go to the embedded wizard website and register and download the studio, and then the platform that you're using. So you got to download the platform. Okay, so after you do that, okay, assuming that you've downloaded everything and you're ready to go, you pick the STM32F746G platform. Now you're ready to create a project. So in order to create a project, you're going to come over here, and then you're going to go to project, and you're going to say new, and you're going to basically, it's going to ask you what kind of project you're going to create. It's either an empty project or let's say, one of these boards. And the board that I'm recommending to use is the STM32F746 discovery board, this one here. Okay, so let's say you selected it. Well, I'm not going to do it because I've done it before. So, and then it's going to come over here. You're going to select your profile. That's the profile. You're using this microcontroller, and you're going to tell it that what kind of a video package you want, and you want to. This is an application class, and then in the profile you're going to say where do you want to generate the code to. So basically, after I compile this, build this project, it's going to generate your code under application generate code directory. Okay, so after you select that, okay, so next what I would do is, okay, this is basically just showing you where it's going to generate your source code. Okay, I would go to the application. In the application, you put in your bitmaps, and there's an inline. Basically takes the code and puts it in your application, that your own native code that you want to write. So the first thing I want to show you is, let's say you wrote this GUI application and you configured it to make it look like something that you like. Okay, so you go pick up these widgets. These widgets are, you just place it like so in the. This is how the GUI is going to look like. Basically, you go pick up these widgets from the resource menu, and then you go in there and then look for, hey, I want a slider, the horizontal slider, and you click and drag it into your GUI LCD display. I want these gauges, I want these sliders, I want these texts that it's going to show some values, and I want this toggle switch, that I'm going to put it here, and then I want like a bevel, and I want like an image area, so that would be under views, and let's see, bitmap image would be this one. You would drag that, and then since I have done it already, you just basically you say, okay, I want that image to kind of look like in this set, take this much of the space on the LCD display. After you've done that, you go into this configuration under that image, let's say, and you want to say, okay, I want that image to be this size. I want it to basically get the bitmap from this class, external bitmap 1 resource. Okay, and you set your color, you set your opacity. That means you can make the image, like overlay the image on other things, and you can see both things at the same time. And you make it visible, not visible, and all that. So these are the parameters. So what I would consider is like, this is the opacity of that image view. So how we get the image into this is basically reading either an external bitmap or a PNG or an image sensor into a buffer and then displaying it. Okay, so after you set up the interface, I mean the user looks that you say, okay, I like this. Okay, so let's see how do I tie this switch, okay, this slide switch on 1 and 0. How do I tie this? Okay, by the way, you can run like a little simulation, and this slide, how do I tie this slide switch to an external pin, the GPIO? How do I toggle it? Well, you basically have to do a few things. You have to write a device driver that's going to initialize the GPIO pins from the GUI application into your hardware abstraction layer. Okay, and it's going to call those HAL functions. So what you do is you go into, let's say, the device driver .c code. Okay, now that I'm just going to close this IDE because I don't need it anymore for now. I'm just going to exit out of here. Okay, so let's look at the device driver. Okay, so in the device driver, okay, okay. So what the device driver does is first it initializes the peripherals. Class. Okay, right here. This is basically upon like reset or power up, the embedded wizard will go and call this method, this function, and it's going to go and initialize all these devices. That's like you configured. So who configures this? You configure it. So how do I do this? Let's say I want to initialize a GPIO pin. Okay, so this is a function. Okay, let's go from here. Okay, first what you would do is you would go unit application. Okay, and you would basically go in here under external devices. And then I would go and drag and drop one of these resources into here. So if I drag and drop it, and then it'll look like this. If I click on it, it'll look like this. So you got an onset method, an OnGet method, and a property. So what does the onset method do? So this onset method is basically tells you to basically go and call this function, okay, and this function calls driver status like set LED status. So it's going to basically toggle a GPIO. Okay, so if I want to toggle this GPIO and I want to basically, under device driver, there's a method. Somebody's going to call this method, and we'll go into that. And before I go too detailed into it, you can read all about this by going to the documentation. So if you go to Embedded Wizard and go into this link here, it will basically show you all the documentation and you can read about it and get your training. This is the documentation and this is the video training for using Embedded Wizard. Okay, this is the GUI application. After you read all this stuff, okay, let's say you know how to do this. Now how we're going to connect the GUI to the hardware. Okay, and that's what I was trying to get to. Okay. So this is Embedded Wizard. If you want to read the notes, how to use it, the tutorials, you go over here and then how it works, the programming language and all that stuff, the studio, how to use the wizard and how to set up all these resources. You can just go in here and then it discusses all the details. But this video is not how to use the GUI. It's basically how to interface to the GPIOs to the GUI. Okay, so here we are. So you put this. There's a function. Somebody you can make this function like EWSP init, and which this initialized driver, this device initialize is going to go in there. It's going to call this device driver initialize. It's built into the GUI, and on all the functions under this will be called one at a time. So it's going to call init LED. It's going to go into here, and it's going to pretty much initialize those. It's that GPIO. And how the GPIO is initialized, here's how the pin is being initialized. So it's going to go init LED, and it's going to set the pins to wherever it's supposed to be set to. Like in this case, it's PI 0 is on the ST microcontroller is set for the GPIO. Now that that is initialized, let's go back into the embedded wizard. Okay, it's going to call this function, like the toggle function, set LED status. And how is that done? So that is basically, you can see over here, that says if not prototyper native, that means it's not part of the Cora. This code is actually C code that it's going to put into the application when it compiles and generates the code for it. And that C code is going to be linked with the GNU compiler and executed during runtime. So this function, device driver status, set LED status with a value, the value is passed to it when this method is called, is going to be residing in here, in the device driver, in this case. Okay, so this is the method, okay, and this is definition of the method, and what it's doing. So if the value is true, then it says LED on. Well, the LED on is going to go, eventually it's going to be like a HAL hardware HAL API function that it's going to call. So if you dig deep into it, it's going to go into GPIO LED. Okay, this is it. Here it is. This is HAL GPIO write pin, GPIO LED, the pin number, and it's going to call this set function. I mean set parameter. So this is the HAL the hardware abstraction layer API drivers that I was talking about. So eventually it's going to call these like low-level drivers to control the toggle the GPIO. Okay, so now that that is done, so how is this all this happens? So this happens during the, let's say, in the application. Okay, you basically it's called Onset Method on LED status. So how this happens? So if I go into the, let me go to the application, and I'm going to go to this guy here, toggle bit. Okay, so the toggle bit is going to pass the value to the set status. So there's an outlet here, and I press it. Okay, let me see if I can find. Okay, right here. So is this outlet? When I press it, it's going to go this. But when I toggle this, it's going to call this application device.led status. Okay, this LED status. So what is that LED status? That's an onset method, which was defined in here. Okay, this is in this device driver on set LED status. So what it's doing is that it's going to basically change this LED status, this property. It's going to make it to 0 or 1, and it's going to pass it to this function is going to be called, and then when this function is called, or the method is called, this method will go and call this device driver LED status function, and then that's going to go and toggle the GPIO bit on the GPIO pin itself in the hardware bit. So this is basically how you going to generate the code to go like high and low, and the GPIOs are used for like stepper motor controls and all that. You know, you can like count number of toggles that you want to do to control a motor to go left or right. So this is like, I'm showing you the function how that can be done. Okay, so how do we, let's say, read an ADC value and put it into like one of these like text resources, visit values. Let's say this counter over here. How does this counter gets updated from an ADC value. So this time we're going to go and read a driver through the driver method. We're going to read an ADC peripheral value. So we're going to call all the HAL functions to the ADC. How are we going to do this? So what we do is basically how it does it. It basically has a timer. You set the timer to an interval to call this slot method. So this timer calls that slot method. Okay, so go to this timer. This timer is going to call this ADC on trigger. It's going to call this ADC slot. This ADC slot is basically going to go and populate this counter resource, which is where this counter resource right here, and it's going to get the string value from this device driver, which is called device2.adc1 method. Okay, so now we'll look into that method next. But so this is the counter, and this is the counter resource right here. Okay, this counter resource. If I can get it, counter resource. Yeah, right here. This counter resource. So this counter resource will be populated with the ADC value. Okay, so we're reading an external value, external voltage, and then translating it to a digital value on the display. So in this case, I'm going to go ahead and show you again how this is done. So in the application, I would go in the device interface. I would drag this in, and when you drag it in, it will come in as like something like this device. Some device like this, device class, device 2, an object. In this object, there's a bunch of methods. One of them is an OnGet method, okay? And it's going to get it, and it's going to populate this ADC1 property, Init32 property. And that's the property that I'm passing to that counter. So how this is read? Okay, well, it's read by this method is going to call this device driver get ADC. And it's going to pass, when it gets the value, it's going to go into temp, and the temp is going to basically go and return this temp and into the ADC property. Okay, so that's how you're doing it. So, and what does all this means? Basically, this is the function device driver get ADC1. Whereas device driver get ADC1, well, you put it into the device driver, which I had done over here. Okay, so there it goes. Here is that driver and function, and then all the function that it needs to read a value from ADC are basically here and here. That's basically it's going to go down and pull an ADC peripheral. If I go deep into it, go to definitions, I will see eventually it's going to end up to a HAL function call, and you're going to read a value. Now here it is, HAL status type def, HAL ADC pole conversion, and all the parameters are passed. It returns the value, and that value gets propagates down to the temp, and then return temp goes updates the ADC. Updating the ADC is going to go into the this method that is triggered by the timer, and this ADC1 property right here gets assigned to counter resource, which is that's the counter resource, which is right here. Okay. So that's reading a value. Now, how do you read a bitmap? It gets more involved. How you read a bitmap is basically, you remember how we put an image section over here. This is what the image bitmap section is going to be displayed over here. Okay, so that image, configuration-wise, it calls an external bitmap. Okay, external bitmap is an object class, okay, which is, let's say, this one, okay. This object class, okay, and it's gonna go, and there has a property called named, okay. I'll get back to this. So upon this property string value, something's going to happen. So I have code that looks at that, and then something will happen, and then return a bitmap pointer to this, which will return it to the image, and then the image will be displayed on the screen over here. Okay. So now let's see how this all works. So in this image, okay, external bitmap, the class resource, there's a load method. Let me just close all this stuff because it's getting cluttered. Okay, there's a slot method called load. Okay, and I click on it. The code is pretty much right here. Okay, so it's basically, it's calling this native code, which is, well, free bitmap, and then it's basically down here. It calls a load external bitmap. Okay, it's calling this native function that I have to create. Okay, and it's passing the name property, okay, which to take action on, and it's going to return a handle. That handle is going to be a bitmap handle, bitmap pointer, and it's going to be that bitmap pointer is going to be a buffer that's going to be populated with the bitmap image. So how is this called? Okay, so this is basically, again, called from the timer goes, and I just put it in the slot. You could have put it in a different slot method. I just put it in the ADC slot. It's kind of like non-intuitive. I should have called a bitmap slot, and that another timer would have called that one. And what it's doing is basically it's saying that, okay, if the I'm setting up, I'm looking at this as property, and I'm toggling it. Okay, so if it's true, it's false. If it's false, it's true. Okay, so on this case, I just check is that property name from the external bitmap one. If it's this, you know, then it go to false. Okay, if it's that, go to, and then basically change the name of the. If it's true, I'm setting that property name equal to this value, the string value. If it's false, set it to this string value. Okay, how does all that work? So there is a C code function that I put in line. Okay. Okay, right here. So when I go over here, this is where I create my bitmap, external bitmap pointer. Okay, this is that external bitmap function. What it does, don't mind all the comments and all that stuff, but the crux of it is that basically it's going to create based on the name parameter. It's going to do if it matches this name, it's going to set up the width and the height of the bitmap itself, you know, the bitmap buffer. In this case, I'm going to set up a 320 by 240, and then by setting that up, now I can create my frame size bitmap here. Okay, I'm going to create the bitmap by using this function, and the format is RGB565. The frame size is what we set over here from the width and the height, and then it's going to return a bitmap handle pointer. Okay, so now I got the bitmap, right? So what I do with this bitmap buffer, I'm going to pass that bitmap buffer to a function, okay, that I want to call. Okay, where is that? After I've locked the bitmap, I'll lock it, and then here it is. Basically, I say, okay, after I lock it, the first pixel I figure out the first pixel and assign it to destination. That's the first pixel of that bitmap buffer. So when I do that, I go ahead and okay, so destination. Okay, down here somewhere there will be a function call. Okay, here it is. So you see I set the destination pointer, right? So this is the function I can call. arducam get bitmap destination pointer, and the OFS is the it's like if it's 2 or 4 depending on if it's 2 bytes or 4 bytes depending on RGB 565 or RGB 888. Okay, so what is this function? So when I put my code in inline, it generates this code and it puts it into this application. Okay, so this is where I took with the code from GitHub was taken, which is the arducam 2 megapixel plus sensor, which is an SBI and I2C interface that goes into like a Arduino type of header, and it reads the buffer, and then I'm going to be transferring that to the bitmap destination buffer. So this here gets put into, generated into the, when I compile it, gets generated into this application.c code. Okay. All right. So here it's generated here, and then of course it's gonna go down to where it gets called. Okay. It gets called here. So here it is my native C code now. Okay. This is where I'm gonna pass the bitmap pointer, which is the destination, and then that I'm gonna start capturing. So go to definition, and then here is my capture code. In this capture code, okay, I go and set up some Arduino sensor registers, clear the flags, and then give it the command start capture. And the start capture is going to go and start capturing the image after, and then I go check a bit. If it's done, then I go ahead and if it's done, I do some error checking if the length has to be a maximum FIFO size. If it's done, then I go ahead and go read the buffer of FIFO in like in the burst into the P pointer. Okay, and so this function reads the FIFO that's filled up in the sensor, and then after that's filled up in the sensor, it returns a pointer to where the buffer is in, and then and I'll take that pointer because I'm reading an 8-bit value, okay, from the FIFO buffer. I have to translate it to 16-bit because that's how the bitmap is. So my 240 by 320 or 320 by 240, actually this has to be 240 height and 320 horizontal width. So I go through it and I say, okay, the low byte goes into here and the high byte goes into here, and then I just set it up in here. Okay, this is where I'm like setting the high and low bytes are being loaded into a 16-bit bitmap pointer, and that bitmap pointer is then at the end of the day is returned, is basically populated, and when it's returned, okay, now that bitmap pointer is returned. That's that destination that I passed from here. Okay, now that buffer is sitting into the external bitmap section of the unload method. Okay, this get bitmap. Okay, so and then it gets loaded here and it's returned. Okay, so basically at the end of the day it's returned, the bitmap is returned to the image display. So because that's where the image display, if you look over here, is pointing to, I don't want to change that, image. Come on, not pointing to the right place. Does it? Okay, image. Okay, as you can see, the image was, what I wanted was the image. Okay, right here, the configuration. I'll bring this down so it'll be clearer. So in this image configuration, you can see that I was pointing to the external, the bitmap was pointing to the external bitmap. So when it returned this, that buffer is returned through external bitmap, which is basically it's pointing to the bitmap. The bitmap of the image is going to be updated, and hence an image is going to be displayed on that image display section right here. So that's basically the crux of it, how an image is being displayed. Okay, now that we kind of talked about how all this is done, I'll talk about like, hey, how I had to set up some of the SPI drivers and all that stuff. Basically, I had to go and look at that ID generated code, and I had to go and update some from the main.c. I had to go in there and put in the initialization of the SPI and I2C and the GPIOs, and where I put them were in it's called the here STM. So basically it basically goes down to this adc.file and hell ADC poll function. This was the ADC, and for the bitmap, I had to go in there and do the same thing for like for the SPI and I2C. So the files that I had to go and update were it was called STM32 746G Discovery. Okay, let's see which one was. Device driver initialize. Okay, device driver.c. Okay. Source. Okay, so the GPIOs were set in this file STM32F746G hell MSP.c from the workspace of the CubeIDE. I went in there and I pretty much copied this file into this directory. Okay. So basically that defines the GPIOs for the ADC, SPI, I2C, and that's generated basically by the IDE, CubeIDE setup. Okay. Then doing that, I had to go and let's say look in my main code. Let's say the ADC initialization function, which is basically this one. And I copied that from my main.c in the workspace of the CubeIDE into this file STM32 746G discovery.c, which is my platform package code. Okay, So that's my platform, and this is where I'm like copying the initialization functions. This is not the only way to do it. This is the way I did it, okay? You don't have to do it this way. You can write your own, like a different file, and then put all that initialization in there. As long as you call those initialization functions which point to the proper ADC or SPI or I2C drivers, and you'll all link it up in the make file on the GNU compiler, like this. Let me show you. So let me see in the make file. Let me look at the make file. The make file, you have to kind of include all those initialization drivers that you call. Like in this case, here is all the drivers, the GPI. Here's the GPIO. Here is the I2C. Here is the UART. Here is the TIM, which is for the PWM. And here is the STM32 Discovery.c. That's the platform. As long as you put these in there, you know, it's gonna compile and link everything up. And these are some board support packages that I created for some of the functions that I'm using, and basically you just have to go ahead and include it in the make file, so it links it all together at the end. So at the end of the day, what you do is, after all this stuff is done, okay, and I'll show you how that, what was this thing called I was talking about, STM32 Discovery.c. Some of the initialization codes I put it in here. STM. Okay, this is not it. Discovery. Okay. Let's say, okay, here is an initialization code. Okay, what is this initializing? Which instance? This is the timer 1 instance, for instance. So this is the function, okay? So mx timer 1 init. So basically this is being initialized, that timer 1 is initializing, and this instance HTM1, of course you have to define it in the declare it like this. This is a type handled structure, timer handled structure, and I had to define it over here. Then in the initialization you load that structure with the proper parameters, and then it goes and initializes all the nuances and the GPIOs for that particular timer, for instance, okay, or SPI or UART. Okay, so I think I've said enough. I'm sure it's a lot to digest. It took me a while to put the video together, and there's a lot of things I probably did not cover, and I will try to make it more and more, refine this video as I go along. Okay, thank you for listening, and we'll talk again. We'll see you again. All right.